Okay, so let's solve this problem. So we have a circle of 50 millimeters in diameter, which is rolling on some horizontal line for a half revolution. And then it begins or it continues to roll on a vertical line for the remainder of the half revolution. Now we want to draw the curve traced out by some point P, which is located on the circumference of the said circle. Okay, so with your drawing board and your instruments, we can begin to solve the problem. I will be using a software to guide you to solve the problem. So the circle has a diameter of 50. So we draw in the circle, diameter of 50. So I am just putting in the radius here. That should be 25. And then it is rolling on some line. So that line should be tangential to the circle at this point. So I will choose to locate my point exactly at this position. So that should be my point P. Now I have to calculate pi d. So to calculate pi d, pi multiplied by d, which in this case is 50, will give me 157.08. So a half of that, because we are doing half of a revolution, is going to be 78.54. So I'll draw that in as my pi r, or half of pi d. So 78.54. So from the center, I have 78.54. Okay, so what I'll do next will be to divide the circle into 12 equal parts, as we always do. So you would have to use your drawing instrument. You either use your 30-degree set square with your pencil, or you can use your protractor or some other geometric constructional means that you are familiar with to divide a circle into 12 equal parts. Okay, so I have the 12 parts. Now we have to label them. So point P is located here. And mind you, we are going in the clockwise direction. So 1, Okay, so once we have this, what we can do would be for us to divide the center line, which is pi d divided by 2 in this case, into 6 equal parts. So now our 78.54 divided by 6 will give us 13.09. So you would use your drawing instruments to do the line division. So I would use offset in the software, and I'm offsetting by 13.09. So these are my divisions. I can label them. So once I have my center in place, now I can draw the horizontal lines which proceed from the divisional lines that I have on the rolling circle. So from 1, then 2, so the line going through 3 is actually the center line, so that's fine. Now we can look at drawing the half revolution of the cycloid in place. We ought to label the center point as well. Okay, so for us to be able to draw the cycloid in place, we have to take the distance CP, and CP in this case is the radius of the rolling circle, which is 25 millimeters. So you take that with your compass, and then we first will have to stand or use C1 as center. So C1 is going to be our center, and then we are looking for the one horizontal line. So the horizontal line named 1, which is this one, right? So we are going to describe an arc on it, and mind you, the radius is 25. So that is point 1. So we now move to the second center, which is center 2, with the same radius of 25. We have to describe an arc on the 2 horizontal line, and that will be point 2. Now we go to center 3. So from center 3, we are looking for the third divisional horizontal line, same radius of 25, and that will be point 3. Now we move to point 4. Now we move to center 4, and then we look for the fourth horizontal line with same radius of 25. That will be our fourth point. And then we move to center 5. Radius of 25. We look for the fifth horizontal line. Now we move to center 6. Still with a radius of 25. And that will be the first part. So we can now use our French curve to draw through the first 6 points gotten to get the first half of the revolution. And that will be the first part, which rolls on the horizontal path. So we do the exact same thing for the vertical portion. So after the first 6 points, the center of the rolling circle would have gotten to C6. So after the first half of the revolution, this is going to be the center of the rolling circle. And of course, with the same diameter of 50, we are able to draw the location, or we're able to locate the circle. And then we can go ahead and divide it. So we go ahead and divide it. Now, after the revolution, the first half of the revolution, the point P will now become located at the very top, or at the apex of the circle. So if we have P located here, and we are going in a clockwise direction, then 1 will be located here. We would have 2, okay, so we can now draw in our center line. The length of the center line, as we calculated earlier, 78.54. So we divide it into 6 equal parts, and each division is supposed to be 13.09. So would continue from there. So to label the central divisions, so would have C1, C2, C3, so C4, C5, and C6. Alternatively, you could have labeled the points on the vertical as follows. So we've drawn from point 1 to point 6. So you could have continued from 7, 8, 9, 10, 11, 12, and for the centers, same numbering. You could have done it that way as well, and that wouldn't have been wrong. So now we can draw the vertical lines from the divisions on the second circle. So from the location of point P, and then from 1, from 2, three is already drawn with the center line, we would keep it. And then 4, 5, and 6. Let's indicate the position of P with a circle like we did earlier. So we now would have to measure the position of P to the center of the circle. So from C6 to P, and that basically is the radius of the rolling circle. So that will be 25. So we can now use our compass, and then with the radius of 25, we stand at center 1. That is our center 1. And we look for the vertical line labeled 1, which should be this one right here. So with that radius, so with the radius of 25, you want to draw an arc. So repeat the same thing with that same radius. Now we move to center 2, just this point. And then we are looking for the second vertical line, which is this one. So we maintain the radius of 25. And that will be our second point here. So we move on to center 3. We So at center 3, the vertical line concerned is going to be the central line. So same radius of 25. We draw the arc. We repeat the process. Now we are at center 4. So we look for the fourth vertical line, radius of 25. That's point 4 here. Next, we go to center 5. And we look for the fifth vertical line with the radius maintained at 25. And we have to do it one last time for our sixth center. And that should go to our sixth line, maintain the radius at 25. Once we are done, now we can connect through using your French curves. So we begin from P to P1, and then P2 to P3, P4, P5, and then P6. And that basically is our solution. But before we go, one last thing, you would have to label all of your points. So from P1, P2, P3, all the way to P6. And then the same thing here from P1 all the way to P6. After the labeling of the points have been made, this will now become our final solution.